Here we are out in the field, the very first ITM standalone CDAC 9139 field test. As you can see here, we've got a customized rig to display all the hardware and sensors. The brains behind the system here is the yet to be released National Instruments CDAC 9139 compact Rio chassis. Windows embedded. Along with the chassis, we've got several input cards here. We've got three 9233 cards collecting 10 channels of accelerometer data. We've got a 9236 module where we're collecting 6 channels of quarter bridge strain data. And we also have a 9239 where we're basically monitoring some battery voltage. The system has been integrated with a cradle point router as well as a wireless air card so that we can connect to the unit during testing to monitor data, reconfigure the setup, and all that good stuff.
In our test monitoring area, we've set up a wireless hotspot that provides us with internet access. This also allows us the flexibility to connect to the chassis from any location using remote desktop or another remote access program. ITM's iTestSystem software has also been installed on the standalone CDAC. This allows us to configure a test by launching the software, and using the built-in configuration tools, we can see all the hardware that is currently connected. From here we can then configure and apply our channels and set up our tests remotely. We can then begin testing our sensor setup.
So here we wanted to display all the instrumentation that we have on the unit. On the unit rack itself, we've got 2 accelerometer channels, one measuring the vertical response and one measuring the lateral or horizontal response. On the front end of the unit, we have 4 accelerometers, all in the vertical direction. We have one located on the lower swing arm and a second one located above the front shock absorber on both sides. In the center of the unit, we've got our 5th accelerometer mounted right above the rear monoshock, kind of the center of gravity of the rider and the unit. So we'll be collecting vertical information there. On the rear axle, we have a triaxial accelerometer measuring 3 directions of acceleration. Here we have our light tack sensor set up with reflective tape on the sprocket so that we can monitor revolutions of the rear axle. In the middle of the swing arm, we have our rosette strain gauge measuring 3 quarter bridge strain levels. Finally, on the brake pedal, mounted on the inside, is a second rosette strain gauge measuring 3 quarter bridge levels of strain.
Our first test using the standalone CDAC was a basic obstacle test that consisted of driving over a series of logs at different speeds and measuring the levels observed by our sensors. To view and record the data being collected by our sensors, we are using the iTestSystem Time History DAC. From here we can view graphs of our data and view our current RPMs. Our next test consisted of us driving our ATV around a creek bed. These tests were done at predominantly low speeds.
Go ahead.
Our final test was done at a motocross track. These tests were predominantly done at high speeds.